Modern automation requires moving beyond simple, linear API requests. A straight A to B data transfer works for basic tasks, but it shatters under the pressure of dynamic, complex, stateful orchestration. To build systems that scale, we use an event-driven architecture like N8N. Instead of relying on rigid scripts, N8N organizes our 13 nodes into a matrix of core categories. First, we have trigger nodes, which act as the instantiation points of the workflow. Next are data nodes, the tools we use to clean and normalize raw information. Then we introduce AI nodes. These function as the cognitive engines of the pipeline, handling reasoning tasks and text generation. To manage the flow of that information, logic nodes control deterministic routing, while action and integration nodes connect the pipeline to external state, databases, and APIs. Mastering N8N requires mapping your data pipeline to this taxonomy. Memorizing specific application connections is secondary to understanding how these underlying categories interact. Let's isolate the first phase of our model pipeline, the form trigger, Google Sheets, and edit fields nodes. The form trigger listens for an event, injecting the raw JSON payload into the architecture. Immediately, an architectural failsafe persists this unedited data into Google Sheets. Next, the payload moves into edit fields. The system subtracts extraneous variables, standardizing remaining fields. Downstream logic gates and AI models expect highly specific data structures. If they receive inconsistent keys or nested arrays they are not programmed to parse, the execution will crash. Normalization at the exact point of entry guarantees a strictly typed schema, preventing cascading mismatch failures deeper in the pipeline. We now pass this normalized schema into the AI block, composed here of an AI analysis node, a text classifier, and a structured output parser. Now, this creates a strict engineering conflict. The language model ingests incoming data, outputting unstructured probabilistic text. This creates an engineering conflict. Natural language breaks deterministic routing logic, as routers cannot read paragraphs. To bridge this, a structured output parser forces the AI's generation into a predefined, predictable schema. Complex cognitive reasoning has now been successfully compressed down into machine-readable Boolean and string variables. Integrating AI in production requires wrapping these language models in strict functional constraints to guarantee format consistency. With our payload properly parsed, we pass it to the logic block, specifically the switch and if nodes. A switch node executes multiplexing operations. It reads the category variable, dynamically routing execution onto the corresponding department track. Next, an if node applies binary gating. It evaluates Boolean conditions, like if escalation is true, routing the item through a true or false output. These sequential logic gates dictate the exact sequence of final action nodes, ensuring that notifications correctly trigger via Gmail or Outlook integrations only when the required conditions are met. The AI provides the contextual reasoning, but the logic nodes serve as the deterministic skeleton that enforces actual business rules. Finally, we address the asynchronous branches of the workflow, utilizing the wait, update record, and aggregate nodes. The wait node manages state by deliberately pausing a specific branch. It holds data until a resolution deadline is met, without blocking parallel branches. Meanwhile, the aggregate node collects and batches historical records over time, compiling them into scheduled trend reports. Outside of this primary pathway sits the error trigger node. Notice that it operates entirely independently from the main pipeline. The error trigger listens globally for a workflow crash. When an execution fails, this node instantly initiates a distinct failover process to alert administrators and preserve system logs. True production readiness is defined by exactly this: a system's ability to manage asynchronous delays gracefully and to execute predefined recovery protocols when encountering unexpected failures. Looking at the complete data lifecycle, we can now trace the entire execution path, from raw data ingestion all the way to asynchronous reporting. We began by capturing events and mathematically normalizing the schema to guarantee structural consistency. We subjected back clean data to cognitive analysis, binding probabilistic language models inside strict output parsers to yield exact variables. We fed those variables into deterministic logic nodes to execute complex routing, all while maintaining independent state and fault tolerance architectures. The taxonomy dictates the system. Triggers start the process, actions perform tasks,
Logic routes data, data nodes prepare information, integrations connect systems, and AI interprets content. Architecting resilient automation requires moving past basic point-to-point connections. It requires translating complex business logic directly into these exact specialized functional categories.